Hello everyone, my name is Dorjee Tamang, student of third semester mathematics honors. Today I'm going to report on C amplifier. Before I got into the topic, I would like to thank our physics lecturer CB Khatiwara who gave such a nice topic C amplifier. So I would like to got on the topic. Firstly, here report on C amplifier. Front page. And secondly, I write my content where introduction, and secondly amplifier, third common emitter, and so and so. So I would like to go on introduction side. So introduction is like this. In electronics, a common emitter amplifier is one of three basic single-stage bipolar junction transistor amplifier topologies. Typically used as a voltage amplifier, it offers high current gain, medium input resistance, and output resistance. So next slide is like this. What is an amplifier? So firstly, I would like to explain what is an amplifier. The amplifier is an electronic circuit that is used to increase the strength of a weak input signal in terms of voltage, current, or power. The process of increasing the strength of a weak signal is known as amplification. What is a common emitter amplifier? The common emitter amplifier is a three basic signal stage bipolar junction transistor and is used in amplifier. The input of this amplifier is taken from the base terminal, the output is collected from the collector terminal, and the emitter terminal is common for both the terminals. And we can see here the figure. And next slide is like this. Common emitter amplifier configuration. Uh, this kind of amplifier includes the signal which is given to the base terminal, then the output is received from the collector terminal of the circuit. But as the name suggests, the main attribute of the emitter circuit is familiar for both the input as well as output. The configuration of common emitter transistor is widely used in most electronic circuit designs. This configuration is evenly appropriate to both the transistor like PNP and NPN transistor, but NPN transistor are most frequently used due to the widespread use of this transistor. And here the input and output figure of NPN and PNP. In common emitter amplifier configuration, the emitter of JPT is common to both the input and output signal as shown below. The arrangement is the same for an PNP transistor, but bias will be opposite with respect to the NPN transistor. On operation of common emitter amplifier. When a signal is applied across the emitter base junction, the forward bias across this junction increases during the upper half cycle. This leads to an increase in the flow of electrons from the emitter to a collector through the base. Hence, increases the collector current. The increasing collector current makes more voltage drops across the collector load resistor RC. The negative half cycle decreases the forward bias voltage across the emitter base junction. The decreasing collector base voltage decreases the collector current in the whole collector resistor RC. Thus, the amplified load resistor appears across the collector resistor. The common emitter amplifier circuit is shown above. Working of common emitter amplifier. The below circuit diagram shows the working of the common emitter amplifier circuit, and it consists of voltage divider biasing used to supply the base bias voltage as per the necessity. The voltage divider biasing has a potential divider with two resistors are connected in a way that the midpoint is used for supplying base bias voltage. And figure is like this, as we can see in the screen. There are Different types of electronic components in the common emitter amplifier, which are R1 resistor is used for the forward bias. The R2 resistor is used for the development of bias. The RL resistor is used at the output. It is called the load resistance. The RE resistor is used for the thermal stability. The CI capacitor is used to separate the AC signals from the DC biasing voltage, and the capacitor is known as the coupling capacitor. The figure shows that the bias versus gain common emitter amplifier transistor characteristics. If the R2 resistor increases, then there is an increase in the forward bias, and R1 and bias are inversely proportional to each other. The alternating current is applied to the base of the transistor of the common emitter amplifier circuit, then there is flow of small base current. Hence, there is a large amount of current flow through the collector with the help of RC resistance. The voltage near the resistant RC will change because the value is very high and the values are from 4 to 10 km per hour. Hence, there is a huge amount of current present in the collector circuit which amplified from the weak signal. Therefore, common emitter transistor work as an amplifier circuit. The slides is like this. Voltage gain of common emitter amplifier. The current gain of the common emitter amplifier is defined as the ratio of change in collector current to change in base current. The voltage gain is defined as the product of the current gain and the ratio of output resistance of the collector to the input resistance of the base circuits. The following equations show the mathematical expression of the voltage gain and the current gain, as you can see on the screen. Common emitter amplifier analysis. The first step in AC analysis of common emitter amplifier circuit is to draw the AC equivalent circuit by reducing all DC sources to zero and sorting all the capacitors. The below figure shows the AC equivalent circuit. The next step in the AC analysis is to draw an H parameter circuit by replacing the transistor in the AC equivalent circuit with its H parameter model. The below figure shows the H parameter equivalent circuit for the CE circuit, as you can see on the slides. CE amplifier frequency response. The voltage gain of a CE amplifier varies with signal frequency. It is because the resistance of capacitor in the circuit voltage changes with signal frequency and hence affects the output voltage. The curve drawn between voltage gain and the signal frequency of an amplifier is known as frequency response. The below figure shows the frequency response of a typical CE amplifier. Input and output impedance of common emitter amplifier. In any electronic circuit design, impedance levels are one of the main attributes that need to consider. The value of input impedance is normally in the region of 1 k ohm, while this can differ significantly based on the conditions as well as values of the circuit. The less input impedance will result from the truth that the input is given across the two terminals of the transistor like base and emitter, because there is a forward bias junction. Common emitter amplifier experiment theory. The main intention of CNPN transistor amplifier is to investigate its operation. The C amplifier is one of the main configuration of a transistor's amplifier. In this test, the learner will design as well as examine a fundamental NPN C transistor amplifier. Suppose the learner has some knowledge on the theory of transistor, the amplifier like the use of AC equivalent circuits. So the learner is estimated to design his or her own process to perform the experiment in the lab. Once the pre-lab analysis is completely done, then he or she can analyze and summarize the experiment with results in the report. The required components are NPN transistor 2N3904 and 2N 244. BBB equals to 0.7B, beta equals to 100 RDC. Advantages of C amplifier. The common emitter amplifier has a low input impedance and it is an inverting amplifier. Second point, the output impedance of this amplifier is high. Third, this amplifier has the highest power gain with combined with medium voltage and current gain. Fourth, the current gain of the common emitter amplifier is high. Disadvantages. In the high frequency, the common emitter amplifier does not respond. The voltage gain of this amplifier is unstable. The output resistance is very high in these amplifiers. In these amplifiers, there is a high thermal instability, high output resistance. Applications. The common emitter amplifiers are used in the low frequency voltage amplifiers. These amplifiers are used typically in the RF circuits. In general, the amplifiers are used in the low noise amplifiers. The common emitter circuit is popular because it's well suited for voltage amplification, especially at low frequencies. Common emitter amplifiers are also used in radio frequency transceiver circuits. Common emitter configuration commonly used in low noise amplifiers. And the lastly conclusion is like this: the common emitter configuration is that the output voltage is inverted with respect to the input signal. That is, the output voltage decreases as the input signal increases. For this reason, the common emitter amplifier configuration is referred to as an inverting amplifier. And the references is like from Wikipedia, RSC journals, Science Direct journals. So here I would like to conclude and thanks for looking my slides, and I would like to end up my presentation here. Thank you.